Hi guys, for today's video we're going to be dealing with proving similar triangles. So when formally proving that two triangles are similar, we need to follow a similar style to congruence proofs. So for example, let's prove that the following triangles are similar. So we've got a triangle here and a triangle here. Let's prove they're similar. It's going to be a very similar approach. You're going to have 4 lines of working typically for similar proofs, just like you do for congruence proofs. However, whenever you're dealing with like these sides, you're pretty much showing that they're in proportion. You're pretty much just calculating the scale factor with using like a pair of sides. So like 7.5 pairs with this 5 here, we can see that the scale factor is 1.5. That is going to be your first line. You don't have to put a reasoning for this. You're pretty much just finding a scale factor. Line 2, we had to show that angle BAC is equal to angle EDF. They're both 120 degrees. And that is given. We have to use that sort of reasoning there because we still are working with the angles, not the side lengths. The next line is going to be the next pair of sides, which are in proportion. They have the same scale factor. So that's kind of ticking off side, the included angle, and another side. So therefore, that's enough to kind of do SAS for similar triangles. And then we finish off with our similarity statement that triangle ABC is similar to triangle DEF. And next to this, you need to show your reasoning. And you can't say SAS for similar triangles. You literally have to pretty much say out, like pretty much spell out the sentence that means that SAS. So 2 pairs of sides are in proportion and the included angle is equal. That sort of sentence is required for your reasoning for these 2 triangles being similar. Note, if 2 triangles are similar via test 3, which was that we have 2 equal angle pairs, there will only be 3 lines in the proof because you only had to show that 2 angles were equal. So line 1 is showing the first angle is equal. They're both 40 degrees, this angle and this angle, and that is given. And next up, we've got the other angle pair, that this and this one are equal to 45 degrees. That is also given. So because we're showing 2 angle pairs are equal, we can then go straight to our similar triangle statement. So triangle LMN is similar to, not equal. Sorry, I stuffed that one up. So let's put our 3 lines there, 1, 2, 3. So triangle LMN is similar to triangle XYZ. And the reason for that is because we have 2 equal angle pairs. Okay, so moving on. So some harder example questions. Consider the following diagram here. So first up, we want to prove that triangle ABC, this big triangle here, is similar to triangle CDE, this little one here. Okay, so the way that we can do this is by looking at some of the side lengths that we've been given for each triangle. We can see that this triangle, this 8 meter side is the hypotenuse of this small triangle. That will match with the hypotenuse of this bigger triangle. So 8 matches with 12. So our scale factor is going to be 8 over 12. This is going to be going from the big triangle down to the little one. It's a shrinking scale factor. So that's a side done. Next up, we can use this angle. This angle is in both triangles. Angle ACB is common to both. So that's a side, that's an angle. And next up, we can do another pair of sides. We've got that the 9 meter side pairs up with this 6 meter side. So therefore 6 over 9 gives us a scale factor of 0.6 repeater, just like up here. So they are in proportion. And this angle here, this in common angle, is the included angle between these sides. So therefore triangle ABC is similar to triangle CDE, 2 pairs of sides in proportion and an equal included angle. So that's going to be test 2. Okay, next up, find the value of X in this diagram. We can see that X pairs up with this 7.5 side. To go from big to small in this case, we're going to be shrinking it. We're going to multiply by this scale factor of 0.6 repeater. So 7.5 times 0.6 repeater. That's the same as timesing by 2/3, which is a little bit easier to do, and that equals 5. So our x is a value of 5. You can see that that side has shrunk down as it should have. Question 2. Chris's shadow is 1.2 meters long, while a 1 meter vertical pole has a shadow of 0.8 meters. A diagram of this is shown below. So here you can see Chris. You can see his shadow down here, 1.2 meters long. And this pole, which is 1 meter tall, has a shadow of 0.8 meters. I'll put the meters in there. Okay, so why are the two shown triangles, which I've shown here, why are they similar? So the answer is, we've got to be thinking about the 4 tests. Which one do these triangles satisfy? But we don't know too much about the triangles yet. So the answer is that both triangles contain right angles. So they've definitely got a pair of right angles there, because we stand up perpendicular to the ground, and poles are perpendicular to the ground as well, so they stand at right angles. And the angle that the sunlight makes with each object will be equal. So the sunlight hits a person and it comes down like this. This angle here will be the same for both of these, because sunlight is pretty much hitting everything on Earth at approximately the same angle. So therefore, this angle is also equal to this one. So there's going to be 2 equal angle pairs. So that's enough to show that 2 triangles are similar. That's test 3. Next up, we want to determine Chris's height. So the idea is we need to figure out what the scale factor is using this matching pair of sides. So let's do the image over the original. So 0.8 over 1.2 is a scale factor of 2/3. This scale factor is shrinking numbers because it's going from a bigger triangle to a smaller triangle. We want to find out Chris's height. Chris's height is going to match up with this 1 meter. We can use the scale factor to go from 1 meter to Chris's height. We're going to be going from our image back to the original, so therefore we need to be dividing by the scale factor. So 1 meter divided by divided by 2 over 3, that equals 1.5 meters. That's how tall Chris is. I hope this helps with the questions. Good luck.